So to introduce this unit, we're going to start with Learning Target 1. We're just going to talk about what it means to be a system of equations and how a coordinate point might become a solution. Okay, so we're going to talk about defining what this unit is about and defining what a solution to a system of equations looks like. Okay, so we're going to define those two things. So first of all, the system, if I call something a system of linear equations, that's a set of equations that have the same variables. So most commonly x and y. And for example, it might look something like this. We're talking about linear equations, so we're talking about variables that, or equations that make lines. So oftentimes you'll see them in slope-intercept form. Sometimes we'll see them in different forms, but they always have x and y. So for example, y equals 2x plus 6 and y equals negative 1/3 x plus 2 or something like that. Okay, so just two equations or sometimes more, but usually two equations together that have the same variables, meaning they both have x and y. Okay, and then a solution to a system of linear equations, okay, would be a solution for all variables that works for all equations in the system, okay? So we're going to look at what that looks like here in a minute, but usually you would write that as either a coordinate point, x, y, or you would just say x equals something and y equals something. Okay, you're going to find a solution, meaning a number, for all the variables, so in this case x and y, that works for all equations. So it should work in y equals 2x plus 6 as well as y equals negative 1/3 x plus 2. So we're going to look at what that looks like here. Okay, go ahead and pause the video if you need to write these down, the definitions as well as the examples that I wrote down, and then we'll go ahead and go on to some examples. Okay, so we need to determine if each of these points is a solution, okay? So I need to determine if x equals negative 15.6 and y equals 0.2, if those are a solution to this system of equations, these two equations up here, okay? So what I'm going to do is I'm going to plug in x and y, and I'm going to see if that's true, okay? So I took my x and I put it in where x is in the equation, 3 times x, and I'm going to see if y comes out as 0.2. That's my first equation here, okay? So I took 47 plus 3x equal to y, and I took 47 times 3 for the x and tried to equal it to y, okay? So I just want to see if these will work. So first I need to take 3 times negative 15.6, and I get negative 46.8. And when I add those together, I can see that they do in fact equal 0.2. So I know that this point is a solution to the first equation. So there's my first step. Then I also need to check it into the second equation and make sure it works for that one. So my work for that one would be 8 plus 0.5x and see if that equals 0.2 as well. Okay, so same x and y, different equation, make sure it works. Okay, so I'm going to go ahead and take 0.5 times negative 15.6, and that's negative 7.8. Get rid of all these lines here for you. See if that equals 0.2, and it in fact does. Oops. So this would be a yes, it is a solution to the system of equations. It works in both of them, okay? Let's check it for this one as well. I'm going to do the same thing again. Let's see if you can follow along with me here. So what I'm going to do is I'm going to put my x in for x in each equation. I'm going to put y in for the y in each equation, and I'm going to make sure that it works, okay? So I'm going to do 2 times negative 4 plus 23 and see if it equals 15. So that would be negative 8 plus 23, and it does equal 15. So I'm good to go on the first equation. Then my second equation, I'm going to do the same thing. I'm going to see if 23 equals 12 plus x, y and x substituted in that second equation. And in this case, 12 plus negative 4 is 8. They do not equal each other. So no, this is not a solution because it does not work in the second one. Okay? So it is not a solution to that system of equations. It works in the first one. It does not work in the second one. Okay? So let's do one more here to see if we're on the right track. If you want to try it first, why don't you try it? And then you're going to pause the video, try out the problem, see if you think it's a solution or not. Then when you're ready, press play, and I'm going to go through what if it's a solution or not, and you can check to see if you're on the right track. So go ahead and pause it, try the problem, press play when you're ready. Okay, so I'm going to plug in here. Oops. Same thing again. If my y is 12.3, I'm going to put that in for the y in each equation. If my x is 2, I'm going to put that in for x. And then I'm going to solve it out. So I'm going to see if 12.3 equals 4.5 plus 5 times 2. Solve that one out here. 5 times 2 is 10. And that already does not work. It's not equal. So I would say no, this is not a solution to that system. Even if the second one does work, I'm not even going to check because I know that the first equation does not work. So no, it's not a solution to that system. So before class, determine if that point, 1.5 and 0.5, is a solution to that system of linear equations. Bring that to class with you when you come. Fill out the form if you have questions.